Today we're going to be talking a little bit about categorical data and how we can represent categorical data. So in chapter 6 we learned about numerical data, where we would have things like the number of minutes played in a basketball game and the points scored during that game. Categorical data is a little bit different. It's where our information is in categories. So it's information that can't be graphed on a number line. So right now we're taking a look at this information, and we have the following information. FAM is conducting a survey for the school newspaper. He surveyed 175 students at his school. He found out that 28 of the students had the new PiPhone, 44 students had a laptop computer, and 110 students had neither. Okay, so if we're going to put this information into a Venn diagram, we're going to have two overlapping circles, PiPhone and laptop, and then outside we have the region for neither. So we already know that 110 students had neither a PiPhone nor a laptop. So if there were 175 students total, and we had that 110 of them had neither a PiPhone nor a laptop, we can subtract those two things to see that 65 students had either a PiPhone or a laptop or neither. All right, so 28 of them had the new PiPhone and 44 had a laptop. So if I were to put this information right here saying PiPhone and laptop, if I add those two numbers together, I get that there were 72 students, because 28 plus 44 is 72. But I know that that's over the total number of students that had those. So that means that I'm not going to have 28 and 44 here. Instead, these two added together have to equal 28, and these two added together have to equal 44. So I need to figure out, what is this overlapping number right here? Well, I know that I've got 72 if I add 28 and 44, but really there were only 65 students. So if I would subtract 65 from 72, I'm going to get 7 students. So that is what my overlap is. So I am going to put those 7 students in here in the overlapping. So 7 students have both a PiPhone and a laptop. So that means of the 28 that had a PiPhone, I can subtract 7 and I will get 21 students. So that's what goes in here. And then of the 44 that had a laptop, I can subtract 7 and I will get 37. So that is what's going to go in here. And now if I do 21 plus 7 plus 37, that should equal 65. All right, so that's how we do that for a Venn diagram. We're going to do the same problem, but we are going to use what is called a two-way table. So you can see here my two-way table. I've got PiPhone and no PiPhone as one of my options here. So PiPhone and no PiPhone. I'm going to have one row for all of the PiPhones and one row for all of the non-PiPhones. And then I also have laptop and no laptop. And these are going to go in a column. So this is kind of what our two-way table looks like. So to give you guys just some details about what each of these things mean, this box right here is our grand total. It is what I get when I add up all of the rows and all of the columns. So 175 students were interviewed. That's what my grand total is. These two spots right here are my column totals. So if I were to add up the number of students who have a laptop and a PiPhone and the number of students who have a laptop and no PiPhone, I would get 44. And then same thing here, these two are going to add up together to give me what I have here. These two entries are my row totals. So if I were to add up these two cells here, I will get 28, and these two cells here will give me whatever number this is. All right, now I have enough information that I can fill in all the spots of this table that I need to. This grand total is what I get if I do 44 plus whatever is here. It has to equal 175. So if I do 175 minus 44, I get 131. Similarly, I can do that with my row totals. 28 plus whatever is in this row has to equal 175. So I can do 175 minus 28, and I will get 147. Now, I can kind of work backwards and say, okay, this plus 110 has to equal 147. So I can do 147 minus 110, and I will get 37 here. And then I can kind of do the same thing down the columns. Whatever is here plus 37 has to equal 44. So I can do 44 minus 37, and I will get 7. Same thing with this row. Whatever is here plus 110 has to equal 131. So I can do 131 minus 110 to get 21. And now I can double check my work. 7 plus 21 should equal 28. Yep, that's right. 37 plus 110 should equal 147. Yep, that's right. And then I can do the same thing down the columns. 7 plus 37 equals 44. 21 plus 110 equals 131. All right, so I know that I have all of the information filled out that I need. Now I can use all of this information. I'm going to kind of get rid of some of the extra stuff here. I can use all of this information to answer some questions about the probability. So just a reminder, when I'm doing probability, I take the number of possibilities that are what I'm looking for, and I divide it by the total number of possibilities. Okay, so what is the probability that a student at FAM school has a Pi phone or a laptop? That's this first question right here. So let's go back to our two-way table, and I'm going to say here are all the people that have a laptop, whether or not they have a Pi phone, and here are all the people that have a Pi phone, whether or not they have a laptop. But I don't want to double count this 7. So I'm just going to do 37 plus 7 plus 21 to get my total number of people. And when I do that, I end up with 65. My grand total is 175. So to calculate the probability that someone has a Pi phone or a laptop, I'm going to say 65 divided by 175. And when I do that, I end up with 0.37, which I can then change to a percent, and it would be 37%. All right, what is the probability that a student has a Pi phone and a laptop? So I'm going to go back to my two-way table, and the Pi phone and laptop is 7. So I would say the probability is going to be 7 divided by 175. So if I do that, I get 0.04, which is a 4% chance that a student has both. Okay, the next question says, what is the probability that a laptop owner owns a Pi phone? So this is super important right here. We are only looking at the laptop owners. So I want to find out what is the probability that the people who own laptops also own a Pi phone. So instead of doing it out of 175, now I'm going to kind of restrict what I'm looking at. I only care about the people who own a laptop. So now I am just looking at this column of the table. So the probability that someone who owns a laptop owns a Pi phone, I'm looking at the number who owns a Pi phone, so 7. And now instead of it being out of 175, oops, I put that in the wrong spot. Instead of it being out of 175, it's just out of the number of people that own a laptop. So that would be out of 44. When I do that, 7 divided by 44, I get 0.16 or 16%. So there's a 16% chance that if you know the person has a laptop, they also own a Pi phone. All right, now let's take a look at the probability that a non-laptop owner owns a Pi phone. So now we are only looking at the non-laptop column. So instead of being out of 175, now it's out of 131. So the number of people that own a Pi phone is 21, and it's going to be out of 131. And when I do that, 21 divided by 131, I also get 0.16 or 16%. These probabilities are the same. There's a 16% chance that if you own a laptop, you will also own a Pi phone. But there's also a 16% chance that if you don't own a laptop, you do own a Pi phone. So when we're dealing with categorical data, we talk about the categories being associated or having a relationship if the probabilities are different. In this case, the probabilities are the same. Owning a laptop makes no difference in your chance of owning a Pi phone, so we would say there's not an association. There would be an association if owning a laptop made it more likely that you would own a Pi phone or less likely that you would own a Pi phone. So if that probability changes, that means that there is an association. So since the probability did not change, since the probabilities were the same, we would say there is no association. You are not more likely to own a phone if you own a laptop.